Hello everyone, in this video we're going to walk through a couple of demonstrations of decision trees in RapidMiner Studio. So go ahead and open up RapidMiner Studio if you have not already. And what we're going to do is actually walk through a couple of the tutorials available within the software. So if you have this screen, you're going to go directly to Learn. If for some reason you closed this, go ahead and go to File, New Process to get that screen back. Click on Learn. And we're actually going to go through a few different steps because I want you to familiarize yourself with the software and the different parts of the interface so that you can have a better understanding of how the decision tree is actually being implemented in RapidMiner Studio. So let's go ahead and click on that first tutorial, the operators and processes. So what you're going to see is we're in the tutorial mode, so it will have instructions on the left-hand panel. You are, of course, free to read through those and proceed as you like, but I'm going to go ahead and point out a couple of other things to you. This middle part of the screen is going to be where you build your process for whatever model it is that you're trying to build. So process is not limited to just model building. You can, for example, simply open up a data set. You can select certain features from a data set. You can clean a data set, you can account for missing values. There are a lot of data preparation steps that you can actually do in RapidMiner Studio before hooking up the prepped data to a node that's going to perform some kind of process that could be a data mining process. So essentially what you have from left to right is you have these little nodes that you can hook up to the different processes. So you have on this side input. So you can drag from here. Very often what we'll do, especially in the tutorials, we'll just pull a process that does not connect to that initial input. And on the left, you have the result side. So you're going to be working from left to right. And what you're going to see is that the processes can be worked with in order to make choices about what you're doing in the particular analysis or what you want to do with your data. So it is abstracted in some sense that you're going to be looking at these processes. They'll look like these little rectangles here once we start to pull them out. And so it's kind of important to just understand piece by piece what you're looking at because it is abstracting it to you as the viewer and the user, but there is a lot going on underneath the hood. There are tools, for example, with Microsoft Azure that work in a similar fashion, or if you've worked with other business process tools, you may have encountered something like this before. So this one is specifically designed for data mining techniques and is geared more toward a learning atmosphere. So I've chosen it for this course for that purpose, that it is kind of a tool that will help you better understand what's going on under the hood and kind of get used to that drag and drop process method. So to complete this first tutorial, we're just going to simply pull out what they call the Titanic training dataset. So this is a data set that is built in to RapidMiner. And if you take a look on the right, let me go ahead and explain some of this. So on the right, you have three different panels. You have operators, parameters, and repository. So repository is going to enable you to connect either to built-in data sets, for example, under samples, community samples, or training resources. You can also connect to local data that is on your machine, or there is a legacy option to connect to database as well. You can also import data. We're not going to do that just yet. We're just going to keep it very simple. The operators panel will be where you can retrieve any operators related to data cleaning, performance indicators, the actual data mining process, really any action that you want to take on your data, so hence operators. The parameters section will help you set different parameters for each operator so that you can make choices that will help your model building. If for some reason you accidentally closed one of these tabs, because you will want all three operators, parameters, repository, all you need to do is go to View and then Show Panel, and then you can select all three individually. So operators, parameters, repository. So if you lose any of these panels, you can just kind of make note of that and go up to View, Show Panel, and bring that panel back. So let's go ahead and proceed with this very simple tutorial. All they want us to do is retrieve the Titanic training set so that we can view it. I'm going to go ahead and hit Next in the tutorial window. So over here, we're going to go to Repository, and we're going to go to samples and data. So the Titanic data set is a very famous data set. It is a list of records of the passengers on the Titanic, the different attributes of each passenger, and whether or not that passenger survived. So you'll see that RapidMiner has 3 different versions of this data set: Titanic, Titanic Training, and Titanic Unlabeled. Titanic Training is the cleanest data set. It's been heavily prepped by the authors of the software for analysis, and so it's good to use for these demonstrations. So what we're going to do, if you want to view the data, you're just going to double click it. If you want to drag it into process for use, then you will just click it once and drag it onto the canvas. So in a typical process, you will not have this background feature with the dots. This is just simply for our training. So even though we are just retrieving data, this still counts as an operator. I'm going to go ahead and hit next. There are 2 different ways to view the data. So we can either just double click, or we can work through process here. So what it's telling us to do next is to click on the output port and drag it over to the result port on the side. Let me go ahead and give that another go. There we go. Okay, so this is technically a process. All it's going to do when we hit the play button is show us the data. So it still counts as a process. This is just getting you used to the idea of dragging out operators. You can, of course, connect to multiple operators, and we will do that shortly. But seeing how you connect this particular operator of just getting the data set, drag the output port to the result port on the side. And now, let me hit next, we're going to hit the run button. So once you have queued up all of the operators in your process, you are ready to run. So I'm just going to go ahead and hit this play button here. And all this particular set of operators did is just pull up the data. So here we can see the very clean Titanic training data set that they have. You have the row number, which indicates the number of what record it is. You can see that we have 916 passenger records in this data set. It actually tells us that up here and on the bottom. And we have 6 regular attributes. So the row number, the age, the passenger class, the sex of the passenger, so whether they were female or male, the number of siblings or spouses on board with that passenger, the number of parents or children on board with that passenger, and finally the passenger fare. We also have one special attribute, and that is survived. It's special only because RapidMiner has marked it as so. We can use this in our modeling. So we're actually going to build a decision tree off of this model, so we can use this to assist with our modeling. So the idea, what we're going to do is build a decision tree that helps us decide, given a new passenger on the Titanic, which of course is not going to be a thing. This is something that happened in the past. But say we took one of these records out of the set that we did not train on, can we build a decision tree that can help us determine, based on all of these attributes, if that passenger was likely to have survived or not? And so we're going to walk through that process. But at this point, all we've done is demonstrated the use of one operator, hooking up the ports, running the process so that we can actually view the data. So I'm going to go ahead and close this window. Also note that you can return to the operators that you've built by clicking on the design view. So you can toggle between design and results. But I'm going to go ahead and close this window and go back to design. So this is the first tutorial, is just simply retrieving data. So let's go ahead and move to the next tutorial. I'm just going to click a couple times. So at this point, we're going to build a decision tree off of the Titanic training set. Now I have to warn you beforehand that the decision tree we're going to build here is going to be built off of all of the records. So this is really just, can we get a tree going that shows us, can we build a tree that tracks the different characteristics of the survivors? So can we look at the tree and kind of see if the people who survived have certain things in common? This is not going to be a good classification model. In other words, at this point, we are not separating our data into a training set and a testing set for the purpose of calculating how well the model performed. All we are doing is just building a decision tree straight off of the data. So at this point, this is just exploratory. We can report these results, but to get something more robust, we're going to have to separate into training and testing. And we'll show you how to do that in the next tutorial. So for now, let's go ahead and build that process. The goal here is to see if the 349 passengers that survived have something in common. So again, we're going to go back to the repository and pull out the Titanic training set. And next, we're going to look for the decision tree operator. So we need to go to operators, and then you can simply search for them. So I'm going to use this capability to just search for decision tree. You can see that there are a lot of types of trees. We are just going to, at this point, use the straight decision tree process. If you're ever interested in more information about a specific operator, you can right-click that operator and go to Show Operator Info. So this will indicate to you what the capabilities of the operator are. So here we can see that the decision tree operator can handle both numerical and nominal attributes. That's very nice. That will come in handy later. Remember, it's really important to be able to identify the type of data that you have in each field. This is one of the reasons why, because then you know what you can actually do with that data. And RapidMiner makes it easy to see what the capabilities of each operator is. If we click on the description, you can see a longer form description of what the operator does and some comparison. So for example, what is the difference between the basic decision tree and the ID3 model, the random forest model, etc. It also gives you information about the parameters and the inputs and outputs of the operator. So in this case, a decision tree is a tree-like collection of nodes intended to create a decision on values, affiliation to a class, or estimate of a numerical target value. So it's going to build the tree and create new nodes until stopping criteria are met. This decision tree does involve pruning, although it can be reconfigured as you see fit. I'm going to go ahead and close this window, and we'll actually drag it out onto the canvas and proceed from here. So if I click next, we already dragged the Titanic training data out. Click next again. We got the decision tree operator as well, so I'm going to hit next again. Now we're going to connect the output port of the data retrieval to the decision tree input port. So if you hover, you can see this is the training set. So if we wanted to, we could make adjustments to the parameters of the default decision tree. We could do that by clicking on the operator and then going to parameters. However, at this point, we will not be doing that. So at this point, we're just going to connect the model port to the result port. And all this is going to do is it's going to read the data, send the data into the decision tree algorithm, and generate a resulting decision tree based on the fact that the Titanic training set already has survived as a special attribute. I'm gonna go ahead and hit next and then run the process by hitting the play button. I'm gonna move this window out so we can see the tree a little bit better. So you can just click and drag. You can also use your mouse wheel to scroll in and out, or use the zoom buttons here. You can change the format of the tree so that it's easier to read or less easy to read. I'm going to go ahead. In this case, the tree is actually the best option, so we'll stick with that. So now what we have is a tree that at the top starts with the first determining characteristic, which is the sex of the passenger. So we take a look, the top node, check the sex of the passenger. If it's female, then proceed down this side of the tree. If the passenger is male, then you're going to proceed down this side of the tree. So let's take, for example, let's say we have a female record. So we're going to go down this side of the tree. Next, we ask ourselves, okay, so is that record for the number of parents or children on board, is that field less than or equal to 4.5 or greater than 4.5? If it is greater than 4.5 for that female record, if we hover over this no node, we can see the number of records that fell into this category and see that for each case where you had a female passenger with strictly more than 4.5 parents or children on board, that they did not survive. So all 4 of these items had no as the survived value. If we take the other branch, so let's say now we're checking records. Okay, so the record is female. The record for number of parents or children on board is greater than or equal to 4.5. The next thing we check to see is on the record, the number of siblings or spouses on board. So it divides on 4.5 again here. If the record had more than 4.5 siblings or spouses on board, if we hover over the no node, we have 2 records in that category and neither one of them survived. If they had less than or equal to 4.5 siblings or spouses on board, then we check the fare. So the more expensive the ticket, it looks like. So if the passenger fare was greater than 35.562, it was really likely that that female person survived. So these are going to be records that had fewer than 4.5 parents or children on board, fewer than 4.5 siblings or spouses on board, and had a pretty expensive ticket. So of those records, 101 of them survived the disaster and 3 of them did not. So again, we're not predicting anything here. We're just simply classifying the records that we do have. So, but we can kind of, at this point, start to see a pattern. You can see in the analysis here that survival was not coincidental at all. In fact, it tells us that as a female passenger with a small family, you were really lucky, at least if you were holding an expensive ticket. And you can continue down the tree to see how each of the records is classified. You can also go down the male side of the tree and see that really the only cases where you survived as a male, well, first of all, they were rare, but they were going to be more likely if you had an expensive ticket. So this is informative. Again, this is not a predictive model. All we've done is classify all of the records that we have, but now you can see how that process works on a data set that is already clearly marked as to what your target is. Of course, this data set was already heavily cleaned. So go ahead and advance to the next tutorial. At this point, we're going to look at the entire Titanic set, so the not so clean one. So I'm going to go ahead and hit next. So here we're going to actually download the Excel file and then import it into RapidMiner from there. So obviously we won't always be using data that's already preloaded into RapidMiner. So let's go ahead and download the Excel file. This window came up, so I'm going to click Download File, and then I'm going to save it in a place that I can find it. You can already see that this has more fields than the training set that we looked at, and that there are no special attributes. So I'm going to take a minute to save this file to my machine in a place where I know I can find it later. I am going to change the format to a regular Excel file before saving. So now I've saved it to my machine. Again, you can see that this is a little bit different. They had that pretty demo data set that we already used. Now we're going to use this one. So we do have some missing data. You can see that there are some ages missing. There is missing data in the lifeboat column as well as the embark column. And we can work with RapidMiner to see how we can work around that. So I'm going to go ahead and close the data set and head back to RapidMiner Studio. Okay, so now that you have saved the Titanic Excel file to your computer, we're going to import it into the repository and then load it into our process. So we're going to go over to Repository tab again and click Import Data. I'm going to choose my computer and search for the location where I stored it. I'm able to find it in my class folder. So I'll go ahead and double click the Titanic dataset that we saved, hit Next, double check that all of the fields are there and that we have the header row indicated, which we do, hit Next, and RapidMiner is going to make some assumptions about the data type of each field, and it will also replace missing data with a question mark. So you can see, for example, for passenger fare that we have a real numerical value, number of parents or children on board we have an integer numerical value, and for things like passenger class, we have a polynomial value. So in other words, a nominal value that takes on more than 2 values, as well as survived. Go ahead and hit next. It will ask us where we want to store the data. So I'm going to go ahead and click the drop down for the local repository and click on the data folder and click, well, before I click finish, let's rename this as simply Titanic and then click finish. So it pulled the data set up and we now have it loaded into RapidMiner Studio, but we have not yet put it in our process. So let's go back to the design tab and click next. So we are going to, at this point, instead of looking at the samples, we're going to go down to the local repository. If you haven't already, open up the data folder where I stored it. And now I have Titanic. So I'm going to click and drag it out onto the canvas. And here's just a reminder that data is not actually loaded or delivered at the round output ports until you run the process. So I'm going to hit next. I do also have this warning here. Some of these warnings are bypassable and some of them are not. If we click on it, it says potential problem detected. So parameter repository entry accesses a repository by name. So local repository up to Titanic. This may not be portable when sharing processes. So this one is one that we can work with. Basically, it's telling me you have it saved in a local spot on your machine and this might not process, that this process, if you run it, might not work on a different machine. That's fine. I'm just going to hit got it and ignore that. So now we'll go ahead and click the output port and drag it over to the result port and hit the play button as indicated. And now we've completed our data retrieval process, this time instead of from the sample, from a data set on your computer. So I'm going to close both of these sets and go back to the design tab. Hit next a few times. And actually, let me hit play again because it's pointing out a couple of things. If we go to, so here we can see the data. If we go to statistics, it gives us some descriptive statistics, which can be useful here. So it looks like we have, for survived, if we click on it, 500 people survived and 809 people did not. If we go down to passenger class, we can see the number of people in each class. So in third class, 709, 323 people in first class, and 277 people in second class. If we click on the details, it gives us some further information. So what the actual value was in the field, the count, and then the fraction or the percentage of records that were in first, second, or third class. So this is a nice place to get your descriptive statistics from. Go back to the design tab. So again, here we were just demonstrating how to load a data set from your computer. So you first have to import it into the local repository, and then you can drag and drop it onto process as an operator. Let's go ahead and move to the next tutorial. So I'm actually going to click on view all, and we're going to move to a different tutorial. I do encourage you to work through these others. These will show you how to filter and sort data, merge and group data, create and remove columns, and change types and roles. However, in this video, we're just going to focus on the decision tree classification, more specifically how to create the decision tree based on a training set, run the tree classifier on a testing set, and report how well the model performed. So back in the tutorial steps, let's go to build a model. And now we're actually going to do some prediction. So let's go specifically to test splits and validation. And what you'll see here is this is going to walk you through how to tell how well your model is going to perform. So again, the Titanic data set is a little bit different because it is just past data that we can't really test new data on. We can't, have the Titanic disaster again. But if this were a scenario that we had past data from, say people purchased certain items during a sale or not, then we could run the sale again and predict how well our classifier would predict whether or not people with specific attributes would make the purchase during the sale or not. So you can see that we have additional operators at work here. That the first thing though is that we're going to again retrieve that training set. So let's go ahead and hit next and grab the Titanic training set again from the samples in the repository. Click and drag it up onto the process window. Now, when you are actually creating your predictive model and building a classifier, what you're going to do is you're going to split your data into training data and testing data. So there are several reasons for doing this. The first is that we can actually build a predictive model by separating the data this way. So basically, we're going to take 70% of the records that we have and use those to train our model. So we just built a classifier on all of the records, which was fine. The problem was that we couldn't then test the classifier that we built on existing data that we already had. And that's what we're going to accomplish here. So we're going to separate our data into a training set and a testing set. And RapidMiner will do this for us as we set up the parameters in split data. It will then build the classifier on 70% of the data, test the results of that classifier on the testing set, so the remaining 30%, and then we'll be able to report how well the classifier performed. So in other words, on that 30%, how well was it able to predict whether or not a new record was that of a passenger that survived or that did not. So let's take a look at how this is going to work. First, we need to add the split data operator. So we're going to go to operators and look for split data. It's this one right here with the funnel. So I'm going to click and drag that out. We have some parameters to set here. So first I'm going to connect the data output node port to the split data port. And then we're going to double click on split data and it's going to bring up a parameter list of partitions. Now what we need to do here is just add 2 entries. The first we're going to mark as 0.7 and the second as 0.3. So what this will do is it will tell the classifier to split the data into 2 parts. So take 70% of the records and 30% of the records. Use the first part as training and the second part as testing. So from here, just click OK, click Next. Now at this point, it wants us to add naive Bayes. This is another type of predictive model, and you're welcome to do that. What I want to show you here, though, is what happens basically if we apply the decision tree. So we've seen what happens when we run the decision tree on all the data. Now we're going to apply this split and run the model that way for the purpose of evaluating its performance. So instead of adding naive Bayes, what I'm going to do is search for the decision tree operator again and drag it out. I'm going to connect the partition port to the training port here. Then I'm going to grab the apply model operator and drag it out. And finally, the performance operator, which this one's a little tricky. Make sure it's just a plain old performance operator, not any of these up here, but just performance. And we're going to connect the decision tree model port to the model port on apply model. This second partition, which is our 30%. So notice that this top partition is our 70%. That's our training set, is going to go into the decision tree classifier. The other 30% is going to come into the apply model operator here and be withheld as our testing set. We're then going to connect the labeled data port to the labeled data port on performance, and finally connect the performance port to the result port on the end. So let's kind of back up before we run and go through what we've done. We pulled out the Titanic training data set. We split the data into 2 partitions. So 70% of the data is going to be fed into the decision tree for the purpose of training the classification model. The other 30% is going to be used to test the classifier generated by the decision tree. That will occur in the apply model operator here. Finally, performance will be assessed and a confusion matrix will be produced. And then we'll see the results. So confusion matrix is just a fancy way of saying we're going to see how many times the classifier said that somebody survived and it was correct, that they survived and it was incorrect, that they did not survive and it was correct, they did not survive and it was incorrect. So we're going to have 4 boxes with a % performance for each of those cases. So let's go ahead at this point and hit the play button to run. And we are immediately given that confusion matrix. So we can see that our decision tree was 79.27% accurate at classifying the testing set. So in other words, it trained on all of those records and tried to figure out, okay, based on all of these different attributes and whether or not the person survived or not, we're going to take in a new record from the testing set, and we're first going to feed that record through the decision tree to see if it classifies it as survived or not, and then we're going to check to see if that person really survived or not. So each of these boxes represents the following. So in the true yes, this is people who survived and the classifier correctly predicted that they survived. These 28 records were people that survived that the decision tree classifier did not correctly predict. Over here we have 141 records that the classifier predicted would have not survived and in fact did not survive. And finally, 29 records that the classifier predicted did not survive, but they actually survived. So there are other metrics that we can look at to evaluate the performance of the model. But at this point, all I'd like you to be able to do is to pull in a data set, to split that data into a training and a testing set in terms of a decision tree, to apply that decision tree, and then assess the performance of the model. So this tutorial has set you up for pulling in new data, for splitting that data, applying a decision tree classifier, and then assessing the performance of that classifier. We will definitely revisit this in person in class. But in the meantime, if you have questions, please let me know.